Hey again, everybody. Mr. Reeves here with you one more time. So in my previous video, I went through classifying real numbers. Remember we talked about counting numbers, which were inside these whole numbers. And as numbers you can count on your fingers, we added 0, and that gave us whole numbers. Integers are those whole numbers plus their opposites. Throw in fractions and any decimal representation of those fractions, and you have a rational number. And then there are some numbers that are irrational, which are not rational, and those are numbers that, when written as a decimal, are non-terminating and non-repeating. All right, so what I'd like to do now is go ahead and just work through some examples that will allow us to see some applications and get some practice on classifying numbers. All right, so it says write all the names that apply to each number. Okay, so it probably would be helpful if we were able to see what those are. All right, so I'm going to go ahead and again, the textbook did not include counting numbers. Okay, so I'm going to go ahead and write it down because counting, or by the way, another name for those, a little more mathematical name, is natural numbers. All right. And then we have whole numbers. Okay. And then we have integers. And then we have rational numbers. Okay. And then over here, I'm going to put irrational because they're in their own separate category. If it's irrational, it's none of these, okay? And then all of those together are real numbers, all right? So right off the bat, I could put for every single one of these, I could put real. All right, because the only type of number that you are dealing with right now is a real number. Again, when you get to high school, you'll learn about something, believe it or not, they're called imaginary numbers and complex numbers that are not real numbers, but everything we have is real. All right, so I'm going to go down here and I'm going to start looking at counting numbers. Are there any of these numbers I can represent on my fingers? And the answer is no. So none of these would be counting numbers or natural numbers. Are any of these whole numbers? And the answer is yes. 0 is a whole number, but none of the rest of these. Wait. What do we have here? I have the square root, negative square root of 100. But what's the square root of 100? It's 10. Right, guys? Because again, 10 squared is 100. So the square root of 100 is 10. So this one right here is also going to be a whole number. All right, actually not a whole number, my bad, because it has a negative in front of it. What was I thinking? It's going to be an integer because integers are whole numbers and they're opposite. So negative 10 is not a whole number. 10 is a whole number. Negative 10 is an integer. However, the square root of 36 is 6. Again, 6 squared is 36. So the square root of 36 is 6. So 6 would be a whole number. And actually, that also means 6 is a counting number now that I think about it, right? Because you can represent 6 on your fingers. Man, Mr. Reeves, you're messing up bad. Okay, that's okay. I caught my mistakes. Okay, so a 0 is a real number. 0 is a whole number. It's also an integer. Anything that's a whole number is an integer. Okay? 6, because you can represent on your fingers, is a counting number. It's a whole number. It's also an integer. All right? All right, negative 10 is an integer. It's not a counting number because you can't represent negative 10 on your fingers. It's not a whole number because whole numbers can't be negative, but it's an integer. Oh, look at this one. Negative 18 divided by 6, that simplifies to negative 3. All right, can you represent negative 3 on your fingers? No, so it's not a counting number, okay? It's not a whole number because whole numbers can't be negative, but it is an integer. Okay. All right. Now let's go back up here 7/8. Well, you can't count it on your fingers. It's not a whole number. It's not an integer, but it is a fraction. So it's rational. All right, what about the square root of 24? Is that a perfect square? Well, let's see here. 4 squared is 16, and 5 squared is 25. So that means 24 is not a perfect square. That puts it over here in the irrational category when you take the square root. And again, just an easy way to check, go ahead and put it in your calculator. All right, I'm going to do the square root of 24, and I get one of those. Oh, it gave me 2 root 6. I need to change this to classic down here because that mode will give me decimals. All right, so it's important to know how your calculator works, huh? Okay, so let's go ahead and press enter. Let's go back to how do we get back to the regular screen here? Where's home? Now let's try it. Okay, let's try this again. The square root of 24. All right, that's what I was looking for. Sorry about that little delay there, folks. All right, 4.8999. So there we go. So that's my decimal that goes on forever. It's a non-terminating, non-repeating decimal. So that's irrational. All right, real whole integer, and it's going to be rational. So guys, let me just stop and just clarify something because this can be very confusing. Okay? Remember, in fact, let me go back to these circles right here. Okay? If you are in the smaller circle, and again, inside counting numbers, anything that's inside the bigger circle or the bigger box is part of it. Okay? It's kind of like those Russian dolls. Have you ever seen those Russian dolls that get smaller and smaller and smaller and smaller? Well, the smaller ones are part of the bigger ones, aren't they? So if it's a counting number, then it's automatically a whole number, an integer, and a rational number. Does that make sense? If it's a counting number, it's automatically those, okay? If it's a whole number, it's not a counting number necessarily, right? It can be 0, for example. 0 is a whole number, but not a counting number. But once it's a whole number, it's those, okay? If it's an integer, then it's automatically rational. So any of the smaller ones are automatically part of the bigger one. And of course, all of these are real numbers. So let me say that again. Any of these smaller ones are automatically part of the bigger one. Okay, so if we go back to where we were, let's see if we can get back to where we were, Mr. Reeves. All right, so once I know it's a counting number, then I automatically know it's a whole number, integer, rational, and real. Once I knew it was a counting number, it had to be a whole number, integer, rational, and real. Okay? Once I know it's an integer, I know it has to be rational and real. Again, once I know it's an integer, I know it has to be rational and real. All right? So 0 was a whole number, therefore was automatically an integer, rational, and real. I only started with real, which is the biggest category, because I knew all of them would be real. Okay, so this one is rational and it's real. Let's go down here to 5.45 again. That's 5.45454545. It goes on forever and ever and ever, which means it's not terminating, but it does repeat. Therefore, it is rational and it is real. All right, 0.75. It's a decimal, but it ends, right? Therefore, it is rational. By the way, 0.75 you should know is 75 over 100, right? Which is 3/4, so it's definitely a fraction. It's rational and it's real. All right, guys, I know this can be kind of confusing, so let's keep going and look at some more examples here. I think they ask us here to put it into the table. All right, so we've got some numbers up here, And again, I'm going to go ahead and add in here counting numbers. Okay, and the book doesn't expect you to do that, or natural numbers, but I want you to know that that actually is a category. Anything you can count on your fingers is a counting number. Add 0, you have whole numbers. Okay, add the opposite of whole numbers, you add integers. Add fractions and decimals that end or have a pattern. All right, and you have rational numbers. Add irrational numbers, and you have real numbers. Okay, so first let's see if we can simplify any of these. That's a mistake I made last time. All right, negative square root of 9 is equal to negative 3. All right, 8.5, we know square root of 16 is 4. Okay, I guess we could write this one as 8.5 if we wanted, if it made us feel better. All right, and let's see if square root of 50 is a perfect square. Well, let's see here. 7 squared is 49, right? 8 squared is 64. All right, so the square root of 50 is not a perfect square. And again, if I went to my handy dandy calculator, which is now set up correctly for me to use, if I put in the square root of 50, I get 7.07, it goes on forever and ever and ever. Okay, so let's classify these. All right, so negative 3. Can you count it on your fingers? No. Is it a whole number? No, because whole numbers cannot be negative. Is it an integer? Yes. Okay, so negative 3 is an integer. And I'm going to go ahead just to clarify. It's an integer, it's rational, and it's real. Okay? All right, square root of 50 we just showed was what? Irrational, right? Square root of 50 is not a perfect square. So it would go over here, square root of 50. It is irrational, and it would be real. All right, 16.6. Is it a counting number? Can you count on your fingers? No. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes. Okay, it has a decimal, but it stops. All right, once you see that the decimal stops, again, it also could be written as a fraction. That's something we'll be working on later. So this one is rational, and it is real. Okay, all right, 257. Now, could you count up to 257 on your fingers? Yes. You don't have enough fingers, but you could count up to 257 on your fingers. So 257 would be a counting number. Okay. And once you have a counting number, then you know you have a whole number. It would be a whole number. It would be an integer. It would be rational. And it would be real. All right. I like those ones best because it's all of them except for irrational. You can never be rational and irrational at the same time. All right. So 8.5 is just like 16.6, right? 8.5. It's a rational number. And it is a real number. Can't count it on your fingers. It's not a whole number. It's not an integer. Square root of 16 is 4. 4 is a perfect example of a counting number, which means it's a whole number, which means it's an integer, which means it's rational, which means it's real. Okay? So this is pretty typical. Out of these 6 problems, we only had one that was irrational, because this box over here, all right, both of these contain infinite amount, but you're going to encounter these ones a lot more than you encounter those ones. All right, I hope that made it a little more clear for you on how things work. All right, let's do a couple examples over here and then we are done. All right, true or false, all whole numbers are rational numbers. All right, so if we go back over here to this diagram, all right, whole numbers is smaller than rational numbers, and it's on this side, so that one is going to be true. All whole numbers are rational numbers. That is going to be true. It's a subset. Whole numbers are subsets. No irrational numbers are whole numbers. Again, if we go over here, here's the irrational numbers over here. Can you be over here and there at the same time? No way. No way. So that one is also true. Okay? That one is also true. That was true. Got it? Okay. So, let me add a couple to these. True or false? All integers are whole numbers. All integers are whole numbers. That would be false, right? Because you can have a number like -7 that's out here but not in there. Okay? So if it's outside, it's not as. All rational numbers are counting numbers. False, right? 1/2. 1/2 is rational, but it is certainly not something you're going to count on your fingers. True or false? A number can be rational and irrational at the same time. False. You can't be over here and over there at the same time. All right. True or false? Irrational numbers are real numbers. That's true, right? It's part of that number there. All right. So those are just some more examples. Again, guys, I understand if you're a little bit confused. This is one of those things where it just takes some practice thinking it through. Having a diagram like this can really be helpful for you. I encourage you to take notes and write down examples, and hopefully that will help you. All right, that's it for this video. Until next time, have a great day. Bye.